In this video, we're going to continue finding the areas between two curves, and you should have already watched the introduction video first, so if you haven't watched that, go back and watch that one first. The problem we're going to look at right now is number 1. And when you look at this problem, there are a few different things going on. You've got two curves, and you've got a shaded area between them, but if you want to do an integral in the x direction, that means you're looking at slices that would look like this. Now, when you get to this point here, B, all of a sudden you're not going down to the x-axis anymore. Now you're finding the distance between these two curves. So you can definitely do the integral in the x direction, but you have to split it up into two integrals. You're going to have one integral that goes from A to B, and it's just the area under f. So that's just going to be f of x dx, and that takes care of all of this area. To find the area between these two curves, you always take the top curve minus the bottom curve, so we're going to have f minus g. So f of x minus g of x is the length of the strip, and we're going to add an infinite number of strips together, and we're going to start at B, and we're going to go to C, and we're integrating in the x direction because we are stacking those strips together sideways. If we add those two integrals together, we'll get an expression for the total area under the curve, which is this first part plus the second part indicated by this integral. All right, so this is just an extension of what you've done before. Now we're not just going to the x-axis, now we're going to have to consider the two curves. There's another way to do number 1, so let's look at the other way we could do number 1. We could also look at stacking strips going in the y direction. Now if we go in the y direction, we're going to start at 0 because this is where y equals 0, and we need to go to this point here. Let's call it m because this is the y value where we would stop. So we would integrate from 0 to m, and we need to figure out the length of the strip. When you're figuring out lengths of strips in the y direction, you always do the bigger curve minus the smaller curve, and the bigger curve is the curve to the right, the smaller curve is the curve to the left. So the curve to the right is g, so we're going to have these lengths will be g of y. Now we're considering everything in the y direction, so we need to have our functions in terms of y minus f of y, and we're stacking these strips vertically in the y direction. So this is a nice way to do this problem because you have one integral instead of two, which is what we got in the dx direction. So both of these answers are perfectly acceptable. They'll get you the same number if you have actual functions and you're calculating a numerical value. What I would like you to do next is take a look at number 2, 3, and 4 and see if you can come up with integrals that would represent the area of the shaded regions, and try to do it in the most efficient way possible. So I won't give you any hints. I'll let you work with your groups if you have the paper in front of you. If you don't, you can just use the video and you can pause it where appropriate. So pause the video right now, and when you guys have a few minutes to work after you've gotten what you think the answers are, go ahead and start up the video to check your work. So here are the answers to the other problems. For number 2, you're going to have to split this into two integrals. The first integral goes from a to b, and the easiest way is to go into the x direction. So you're going to do the top curve minus the bottom curve, which is going to give you f minus g, and then you're going to add that to the second integral, which goes from b to c, and the top curve in this half is g, so you're going to do g minus f, and you're doing everything in the x direction, so that's a dx. For number 3, this one's very similar to number 2, but now you're going in the y direction. Now when you start your limits of integration, always start at the bottom at the smallest number, which is p, and go up. So our first integral goes from p to m. So we're going from the smaller number up to the bigger number, and our bigger curve is to the right, so we're going to do g minus f for that first part. Our second integral is going to go from m up to k, and our right curve is f minus g. So this also has to be broken up into two parts, and the easiest way to do this one is in the dy direction. Number 4, this one, the easiest way to do this is in the y direction. So if you stack all these pieces in the y direction, if you go from right to left up until you get to the x-axis, you're going to have g minus h. Once you get to the x-axis, you're getting to where y equals 0. Now, all of a sudden, your right curve is f. So at that point, you have to split. You have to split into two integrals, and the point at which you split is where y equals 0. So our first integral goes from n to 0. Our right curve is g, our left curve is h, and then we go from 0 to m. Our right curve is f, and our left curve is h.